2 kilometers beneath the Swiss Alps. A train is moving at 250 kilometers per hour. Above it, mountains taller than skyscrapers, millions of tons of rock, and passengers barely notice. This is the Gotthard Base Tunnel, the longest railway tunnel ever built. 57.1 kilometers of precision engineering. But here's what makes it extraordinary. An entire country voted to build it. It cost over $12 billion. It took 17 years to complete. 9 workers lost their lives. And at one point, engineers drilling from opposite ends of the Alps had to meet perfectly, 57 kilometers apart, with only centimeters of margin for error. If they missed, the consequences would have been enormous. So how do you drill through one of the most unpredictable mountain ranges on Earth without collapsing it, flooding it, or losing control of the project entirely? To understand that, we have to go back to when the Alps weren't a tunnel. They were a wall. For centuries, the Alps divided Europe. They separate Northern Europe from the Mediterranean world. Economically, culturally, geographically, merchants crossed narrow passes. Armies struggled through snow and avalanches. Trade moved slowly and unpredictably. Even in modern times, the challenge remained. By the late 20th century, Europe's economy was expanding rapidly. Trade between Italy and Germany intensified, and thousands of heavy trucks roared through Swiss alpine valleys every single day. The result? Noise pollution, air pollution, strain on fragile ecosystems. Small mountain towns became freight corridors. Switzerland faced a decision: allow road transport to dominate its landscape, or redesign how goods moved across Europe. What happened next was unusual, because this wasn't decided by politicians alone. Convincing an entire population to spend billions drilling through mountains? That required something rare: public approval. In the early 1990s, Swiss citizens voted in a national referendum to protect the Alps by shifting freight transport from road to rail. The public approved. This mandate led to the new rail link through the Alps. At the center of that plan was a bold idea: not another winding railway over the mountains, a nearly flat rail line drilled straight through the base of the Alps. Supporters saw long-term environmental protection. Critics saw massive cost and risk. But once the vote passed, Switzerland committed, financially and politically. Now engineers had to turn that vision into reality. And the first problem was simple: the Alps are not simple. Traditional mountain railways climb steep gradients. They curve, spiral, and fight gravity. That limits speed. It limits cargo weight. It increases energy use. Engineers proposed something radically different: a base tunnel, almost completely level. The Gotthard Base Tunnel stretches 57.1 kilometers from Erstfeld in the north to Bodio in the south. At its deepest point, it lies approximately 2.5 kilometers beneath the surface. Inside are 2 parallel single-track tubes, cross passages every 325 meters, 2 underground multifunction stations. This design improves safety and ventilation while allowing high-speed travel. Freight trains no longer need extra locomotives to climb. Passenger trains can travel up to 250 kilometers per hour. On paper, it was elegant. But the Alps were about to test every assumption. Because the mountain wasn't a single block of granite, it was fractured, pressurized, water-filled, and in some sections dangerously unstable. The Alps were formed by tectonic collision. Their geology is chaotic, layers compressed and twisted over millions of years. Engineers encountered hard granite that destroyed cutting tools, soft rock that threatened collapse, fault zones filled with pressurized water. In certain areas, water pressure could burst into the tunnel at dangerous speeds. Underground temperatures reached up to 45 degrees Celsius. Ventilation systems became essential just to keep crews operational. Progress varied dramatically. In stable sections, machines advanced quickly. In unstable zones, progress slowed to just a few meters per day. Every meter required monitoring. Sensors tracked rock stress. Geologists analyzed core samples constantly. And all of this led to one critical moment, when the two ends, drilled from opposite sides, had to meet. After years of excavation, if they were off by even a few meters, the consequences would have been severe. To drill through the mountain, engineers deployed 4 massive tunnel boring machines, each extended over 400 meters long. Each weighed thousands of tons. At the front was a rotating cutter head equipped with hardened steel discs. These discs crushed rock under enormous pressure. Behind the cutter head, conveyor belts removed debris, hydraulic systems stabilized the walls, crews installed concrete lining segments. The process was continuous. Excavate, reinforce, advance. More than 28 million tons of rock were removed. And in 2010, after years of precision drilling, the two ends finally met. The alignment error? Just a few centimeters, across 57 kilometers, a level of precision that remains astonishing. But machines weren't the whole story, because building 2 kilometers underground for nearly 2 decades comes with risks most people never see. More than 2,600 workers contributed to the project. They worked long shifts in heat, dust, and confined spaces. The air was heavy, the machinery constant. Despite strict safety measures, accidents happened. Rockfalls, equipment failures, flooding incidents. 9 workers lost their lives during construction. Behind every kilometer of progress were people operating in extreme conditions. Megaprojects are measured in steel and concrete, but they are built by human endurance. After 17 years and $12 billion, one question remained. Was it worth it? Construction began in 1999. The total cost reached approximately $12 billion. Critics questioned whether rail freight would truly replace trucks, whether the scale justified the expense. Switzerland financed the project partly through heavy vehicle taxes, ensuring road freight helped fund rail alternatives. In June 2016, the Gotthard Base Tunnel officially opened. World leaders attended. Trains that once took hours navigating mountain routes could now cross the Alps in roughly 20 minutes. Travel times between Zurich and Milan dropped significantly. Freight became faster and more predictable, and truck traffic through alpine valleys declined. But the biggest change wasn't just speed, it was structural. It reshaped how Europe moves. The tunnel strengthened the north-south freight corridor between Italy and Germany. Rail became more competitive for long-distance cargo. CO2 emissions were reduced. Sensitive alpine regions experienced less heavy truck traffic. The Alps, once a barrier, became a conduit. Switzerland demonstrated that environmental protection and economic growth do not have to compete. Infrastructure can serve both. And perhaps most importantly, a small country proved that long-term vision can reshape continental logistics. Deep beneath snow-covered peaks, trains glide silently through solid rock. Passengers look at their phones, sip coffee, unaware of the scale surrounding them. 57 kilometers, 2 kilometers underground, 17 years of construction. The Gotthard Base Tunnel is more than a railway. It is proof that geography is not destiny. When democracy, engineering, and persistence align, even the Alps can be opened. If you enjoyed this video, don't forget to subscribe to the channel. We'll keep bringing you more fascinating mega projects, engineering marvels, and stories that reshape the world.